In today's video, we'll be talking about thin film interference. After watching this video, you should be able to explain how thin film interference can occur. All right, so let's get right to it. So what the heck is thin film interference? Well, I'm sure you probably have experienced one of these phenomenons that I'm just about to talk about. I don't know if any of you guys have ever seen streaks of color on a windshield after you've wiped your windshield down with a squeegee at a gas station. Or have you ever seen colors on water when there's a thin layer of oil floating on top? Or have you ever seen colors in, say, a bubble that you've blown from a bubble solution? All of those are examples of thin film interference, and we'll talk about how that occurs right now. So I realize there's a ton of text on these slides, and you're probably going to have to pause the video through different points, because basically I'm just going to explain how all of this occurs, show you a picture, and then that'll be it. All right, so feel free to pause as needed. But remember, light wave interference occurs when two waves meet up in a medium. And basically you can have two types of interference, right? Constructive interference, which is going to enhance the light wave, or destructive interference, which basically cancels out the light wave. Okay, so when a light wave reaches a boundary between two media, so for instance, light that's in air now reaches a water boundary, a portion of the wave will bounce off of the water and just stay in the air, okay? But another portion of it is transmitted across the boundary, all right, and enters into, say, the water or whatever it is that new boundary is. So this reflected portion, it stays in the air, which is what we'll be talking about primarily, is that's in air. And the transmitted portion enters the new medium and continues traveling through it until it reaches the end of that boundary. Okay? And again, there's a ton of text on the slide, and I think that the picture after I go through all the text is going to help explain a lot of this. So I mean, just bear with me as I kind of go through the text. So if the new medium is a thin film, then the transmitted wave does not have to travel very far before it reaches a new boundary and undergoes the usual reflection and transmission behavior. So what ends up happening is basically there are two waves that emerge from this thin film. One wave that is reflected off of the top of the film, and another wave that reflects off of the bottom of the film. Okay, so let's get to a picture that will hopefully help explain this a little bit better. Okay, so here, this is the, we'll say this is a ray of light, okay? And it's in air right now, which is labeled right here, and it hits a film, and we'll call this film oil, okay, just because I think that's something we can relate to. And notice this oil isn't very thick, okay, so the light ray can do one of two things. One, it can enter into the film, or the oil, or it can reflect off, and that's what wave one is. This is just a reflection off of the oil, okay? But part of this light ray enters into the oil, and it doesn't have to travel very far. This is a very short distance from here to, say, here. And now it hits this new boundary of oil, and we'll say there's water under here, okay? It hits this new boundary, and what I'm concerned with is this piece right here that basically reflects, so this is a reflection, off of the edge of the oil-water boundary, and then it enters into the air again, right? And so this is actually what's called diffraction, but that's not really that important at the moment, okay? So what you end up having is here are two light rays exiting from this thin film, okay? And what ends up happening is basically you will get constructive and destructive interference occurring, okay? Who cares, right? Well, that rainbow-like color that you see, the colors that you see, so sometimes I'll see like purples or blues kind of floating on top of water when you have oil there, that is all constructive interference. Basically, those colors are being enhanced because two light waves are exiting the film and you are going to your eye. Like if you want to draw an eyeball here, you certainly can. There's your eyeball, and there's some eyelashes. Are seeing basically light waves that are being enhanced or constructively interfered. Anything that's being destructively interfered, you would not see. It's destroyed, if you will. Basically, it's canceled out by the two light waves that are exiting the film. Okay, it is a complex thing to wrap your mind around, but once you if you just think about it for a while and kind of go through what I just said, I think it'll make sense. Okay, there is some criteria for this constructive interference to actually occur. All right, the two waves must constructively interfere with one another for us to see anything. Okay, they must constructively interfere. They destructively interfere basically means they cancel each other out, and so you wouldn't see that color, for instance. So if red is being canceled out, you will see no red. Okay, but if purple, for instance, is being enhanced or constructively interfered, you'll see a lot of purple. Okay. So what's really crazy is the film must be a perfect thickness, and it gets into some really icky math that we won't really have to deal with in this course. It's beyond the scope of it. But when you start calculating the thickness of the film, that thickness, as it varies, that's going to cause different colors to be enhanced. Okay, so that's why if you blow a bubble, you'll sometimes initially see certain colors, and then as the bubble starts to kind of thin out, you'll see new colors forming because the thickness of the bubble is actually changing. All right, so whatever frequency is being enhanced is what color is visible to our eyes. And basically, thin film interference is another example of why light can be considered a wave, because you have constructive and destructive interference going on. Okay, so that takes care of this video. I will see you guys next time.